Hi everyone, I'm Eric Johnsrud and I'm going to go over our infrared array sensor, GridEye. So GridEye is a passive thermal sensor similar to the PIRs that Jeff just went over briefly, but there's a major difference between them. Our GridEye sensor is a always looking sensor where the PIRs are looking for a detection event. What that means is that this sensor is constantly giving you data of what it's seeing so that you can use this for more types of detection. So the advantages of that is that this sensor is able to detect motionless objects or even the direction that a moving object is going in a given space so that you can do better tracking. These sensors are also useful for temperature measuring and thermal imaging. So these can be used for human detection, such as people tracking in a given space, or even gesture detection on an object. So the way that the GridEye works is that it has an 8 by 8 pixel array. So that's 64 different data points that it's constantly streaming out. From those data points, you can then use software in order to identify what's going on in the given space. There is a ASIC inside this sensor that allows for some processing, but a lot of it has to be done externally. So here are the specifications for the GridEye. There are four major types, a high gain and a low gain type with a 3.3 volt drive and a 5-volt drive. Currently, we have a 60 or 36.5 degrees lens, and we have a 90-degree lens that should be coming out shortly. For the high gain, it's a better accuracy, but a tighter temperature range that it can see. So the accuracy is about 2.5 degrees C for the outer pixels with plus or minus 1 degree C on the inner pixels, with the low gain being plus or minus 3 degrees C on the outer pixels with plus or minus 2 degrees C on the inner pixels. There's also, so the detection range for them is 0 to 80 for the high gain and minus 20 to 100 degrees C for the low gain. These sensors all communicate via I2C, and they have a selectable frame rate of 1 frame per second or 10 frames per second, depending on what you're detecting. So this is going to show some of the software that we have available. We have various amounts of software that can be provided to you with a software license agreement, which is at no cost to you, but as long as you're buying the sensor. So this is one of the human detection software. So this is showing the sensor in the upper left with the raw image. We then interpolate that up in order to get a better viewing area. Then we take a background image from the area. And then through differentials, we are able to see what is going on and what is changing in the environment. From that, we identify, apply some logic to detect what those are, to then track the existence of a person. So while the sensor won't be very good on a moving object, this can be used in the given area to identify what's going on and being able to kind of tell the robots what's going on in a given space. So you can see as the people start to come into this room, they'll quickly be able to identify that a change is happening and start to identify a person and then output that there is somebody in that given space. This sensor ideally works looking at a given space that's not moving because it needs to have that differential image in order to calculate the person in a given space. So this sensor is very useful for controlling a given area to identify what's going on in that space, as well as being able to identify who's going where so that you can have an area that where your robots are that needs to be controlled with people so that when you know that somebody's in there, you have the robots on more concern. But once those people leave, the robots can go back up to the full speed. So this is just showing again that the sensor can be identified someone's going into an area and then also identify that they are leaving a given space by identifying the direction of travel each way. Okay, thank you very much.
Panasonic Industry